Welcome to another GCBASIC video. This one is actually trying to debug the I2C interface on the Q24 chip. Let's get into the video. Right, what I'm trying to do is implement I2C, and I've called it the I2C challenge because I always know it's going to be a challenge, and this chip is slightly different from what's gone before, which is different from what went before and before and before. Okay, so I'm doing a series of videos. I got down to number 11, where I wanted to show the I2C devices on the bus. It was really simple. It works really well in software, I2C, and I've shown that in the previous video. So this is a bit of an update. Don't need to go through what the compiler is. Open source does PICs, AVRs, and LGTs. And it's what I'm doing is now what I'm going to show you is pretty well different from what I've shown you ever before. Okay, so pen. I'm going against my principles. I am going to ignore all the libraries this time. No libraries, okay, because I have to fix it. And that way, if I ignore all the libraries, then I'm just basically taking my source code through the preprocessor, out through the assembler. I'm actually going to be using GCBASIC because I feel very confident about it. That is correct, and I will produce a machine code file. Now, what I'm going to show you is the result of 2 days of work. Okay, so I know GCBASIC works. Okay, I have got a prototype board. I've shown that many times, and I've got a 28-pin device loaded, and I've got some I2C devices attached. Now, what is really important, and I don't know if this is the root cause of the problem yet. That'll be probably day 7 before I get to that. You take some coffee. Is I have moved the SDA from C5 to C3, and I'll explain why. I noticed, well, previously, let me just draw some lines. Previously, I had, purely for convenience, I had the SDA and clock on there. And then when I was doing one of the microchip videos, which I have submitted to Microchip are supporting me on this. That's not the Microchip Forum, which I'll speak about, but Microchip support. I was doing a video and I thought, hold on a minute. This domain stuff, okay, let's recap what the domain is. This is a power domain, it's green, and I have to apply power to VDDIO2, and I've got 505 applied to that because that's the operating voltage that I want. And I had it connected to these two here, RC5 and RC4. I have TX on here, serial. Well, I happened to notice this little word down here that said I2C SM bus compatible. What did that mean? I've asked Microchip, what does that mean? They haven't told me because they don't know yet. They are waffling on about TTL signals, but that makes no sense to me. So I have moved SDA to here and asked and the clock to there. Now, I moved it, but I also changed something else. So later on today, I'm going to revert back to RC5 to see what happens. I don't have a working solution for GCBASIC yet, as I'll explain, but I have moved to what is the I2C SM bus compatible ports in there, those two, RC3, RC4. I've got it pulled up, devices. Oh yeah, Microchip asks, oh, have you got pull-up resistors? Yeah, yes, this is a standard board. I've used this thousands of times over the years, okay? And it works. It works on software, so why wouldn't it work on hardware? And all I was trying to do, if you remember, is trying to get these two numbers on my screen. And that would prove to me that the hardware solution is working. And what I mean by hardware solution is that's from the user code to the library to all the components inside of the libraries that actually make the hexadecimal file. For without seeing that, I would not proceed. Another mouthful of coffee. So that is really important, and I advise everyone to do I2C discovery before you try anything, because this is a classic case of things not working. All right, so what have I done? I opened up a ticket with Microchip, but more importantly, I opened up a question on the forum. And the forum's really good to me. They are generally good people, okay? I'm a pain, I know, but these are generally good people. And we'll just zoom in on what I posted. So I posted this. I said I'm having some experiences with Q24 using PIC-AS. Why do I say PIC-AS? Because we can generate PIC-AS source and it gets rid of, oh, it's GCASM. No, I've tested all this in PIC-AS and I've been testing this for a while. For a while for me, by the way, is 3 days. For a normal person, that might be 3 months. But truly, I know something's not right. And I gave them some background that we're quite good at doing this. And I'm getting some very spurious results. Like I send 78 and then I get a load of zeros. I go on to give them my code and it looks just like C code because I've done this before. You don't go posting GCBASIC code because they get upset. Now, one thing that is interesting that I had. Now, I took this from the manual, by the way. I took this from the routine in the manual, page section 37, 4.2, 7.1, whatever. Okay, all right. And I have encoded that, and it didn't work. So I was pretty confident there was something I missed somewhere. Okay. And then I then did some. This is the actual sender bytes. This down here says set the address to 78, set the data byte to 55 hex, and send 1 byte. Blah, away you go. And as of course we were getting rubbish. Okay, all right. Now I was getting a problem on the C-based projects too. I have put that down to the fact that I was using C.5 and C.4, not the SMB I2C compatible ports. So I posted that. Lots of questions, blah, 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 lots of questions, blah, blah, blah. I respond back. Then, blah, blah, blah. This guy responds back. I'm sorry, but he was just completely left field. I have to ignore that. I then posted a new video, the video that you've been watching, hopefully. And then this guy, Howard Long. What a gentleman. Okay, what a gentleman. Because he went into some detail showing me what he had done, and he then posted his code, his source code from C. And do you know what? It's a standalone piece of code that doesn't need any libraries inside of MP Lab. Oh, that's what we do. But he's got it in C. But it worked. It works, he says. So I go, I am very grateful for the level of detail. I then took that code, and guess what? It operated absolutely correctly in MP Lab. I just took his code, created a project, took his code, pasted it in, and guess what? Wacky, wacky. I got exactly what I expected. What was different, I thought. Anyway, leave that. And then I converted to GCBASIC, which I'll show you shortly, and it worked exactly the same. Remarkable. So where is the problem? So this is the code. We'll look at that in a moment. Then I got into some long debate around some of the issues inside of PIC-AS, okay, and the debugger. Let me just show you that. A bit of a debate in here about the debugger. Let me show you in PowerPoint. I was trying to debug the code, and as I was debugging the code, I got a little bit confused because I was this on the right here, where it says debugger is MP Lab debugger, and on the left is the list file created by PIC-AS. And if you look at it, the address on the left for a register called I2C1 con 0 is 658, and on the right, it was actually transposing that to SPI. Oh, SPI2 con 1. I'm so sorry. There's a number missing from in there. Never mind. But with a bit of 5, and it turns out that the debug is broken and has been broken forever, and I'm not to rely upon it. And I would be fighting a war to get it fixed with Microchip. Unacceptable. to be quite frank. This is unacceptable. That they are stuck. Essentially, all their registers are addressed as bank 0, and it just ignores everything else. I'm sorry. It is it is very resolvable, and we have resolved it in GCBASIC. So I banged my head against the table. Then we got into some big debate. Ooh, I don't know, going on and on. And then I showed them some of the other tools that we have in GCBASIC, like bank check, which actually checks out banks. And the issue is that we have to treat everything as an unknown bank or unknown page, and then we resolve it within the compiler. It's not hard to do. Okay, Hugh did that when he was about 15. Right, so let's go back into where we are, me ranting. Okay, so hopefully you can see my screen. Now I'm going to zoom in, I guess. I will zoom in quite a bit. There we go. Look. Now I've got my little toy here that I record on minimized. Here we go. What I did, I took the code, as I said, from MP Lab. This is the code that was posted, look. And is this the code that was posted? Yep, this is the code. I just pasted it into here. It says on here, 2024, 11/28, which was a few days ago, and it works, it says. And it did work. I was able to debug it. How did I debug that? If you remember, I've got this thing here. This is actually a virtual machine that you're seeing. I don't keep, for performance, I keep my debugger on a completely different machine. And I then debug it. And as you can see, it's sending out data. And I captured that a few moments ago. And I'll minimize that. So it was working. So I took its code, almost verbatim, and just pasted it into GCBASIC, okay? And eventually what I did, I said, okay, here's my call out to what his routine, which is called transmit bytes, 78, which is my address, and I'm sending a byte, and that says string to byte. So where did it get? It sends it an incremental change. I don't want to go into everything that I did, but I'm using the automatic version number and time routine by adding this including. This include just creates me a version number. Then I send that version number out to my debugger and into my systems so I can check it's actually incrementing through. Then I know I'm not looking at the same data. If I was sending out the same number every time, I wouldn't actually know if it changed. So this number will change. This will increment up. It will always hunt for 78, and it will always hunt for the value of this byte, whatever that is. And we'll see that in a minute. And then it completes. So what's going on in here? I've got a routine that actually sets the serial, sets the clock and the data port to an output, sets the PPS, and then this is essentially the code lifted from the C program. Slight tweaks, doesn't really matter. Then I added this in because that was an errata statement, so I put that in. Then I used his variable names in the subroutine, that is the transmit, which says that's a byte value, I2C address, byte value, I2C address, pointer byte to a variable called TX data, and a byte number of TX bytes, and that's the length. So what you've got is the address, the data you're sending out, and the number of bytes. Now, at the moment, I'm just sending out 1 byte. I've hard-coded it to 1 byte to keep things really simple. Then things changed. And I'll do a diagram on this in a bit. Because he says in his code, wait for the bus to be available. And that means that the bus being available means that the SDA and the SCL must both be high and free. Okay. If the clock is low, it means that something's actually got the clock low, holding the clock low. That would be bad. So you couldn't actually send any data because someone else is already clocking something out. And if the data's low and you can't control the data line, then you already know that there's a transmission going on. So the only way that the bus would be available is when both lines are high. And that basically this bit in this register waits for that. And these no ops just let it cycle through. And I've timed it and looked in the debugger. And it takes 4 cycles just to get the thing settled. So it sort of checks it 1, 2, 3, 4, and then voila, you're through. Same as we had in the original code that wasn't working, which is to put the address in there, the number of bytes. Well, that's always going to be set to 1. Put that in the counter, and then he sets the start high. Then things are different. Again, he waits for the S to go low. Oh, so do while .s equals 1. Well, we'd already set it to 1. So this is actually, to be honest, it works, but I'm never going to be able to I can't accept that as a piece of library code. Because if the S never went low, this would lock the whole code. So I will then add, as I develop this over the next day or two, I will add in the error checking that's within our libraries. But look, all it's done is said, wait for the line to go low, set the address, set the bytes, set the start, load some data, great, load some data, send the data, which is the data byte. And it says here, I'm so sorry, that's send the data byte. That's load it into that register called TXB. And then it waits for the buffer to become empty, which is TXBE, empty. TXB, empty. TXB, empty. Wait for that to become empty. Job done. Wait for the stop bit. How do we know? Well, you can't wait for the stop bit because there is no stop bit in this chip. So what he does, he waits for the master address to stop operating, and that's a signal that the stop has been issued. Function key F5. Let's go into the VM, start this. By now it will have programmed it. Okay, I'm going to hit that little icon there, and it says here that it sent out 78 or 12 because I've changed from the C code to GCBASIC code. 78 or 12, which is hexadecimal. 12, which is decimal. 18. Okay. There we go. Why would that be correct? Let's look at our source code. I'm doing the 19th build. I am looking for the 19th build, not the 18th build. Let's have a look. 13, hexadecimal 13. That's exactly what I'm looking for. So I can now from what this code is doing, it's different because this is nothing like the specification inside of the datasheet. The datasheet doesn't say do this. The datasheet says load the address, load the number of bytes, load the first byte into the register, then say start, then load more in. The datasheet is wrong. It has to be wrong because that's what I did. I have not looked at where I got to in here, but if we could look in here for a moment, go to the bottom. This is the I2C library. Now in here, there's quite a lot of other stuff because of all the debug, right? Not the debug, the error checking. We need to figure out error checking. So in here, it comes through, it sets the address, same, it sets the number, it sets the count, exactly the same. If it's the first run through, it loads, well, it always loads the data because it's actually loading a buffer here, and then it loads the start. This is the start signal here, okay, all right? Because I just put I put a little test in it, but this was a bodge up because I was trying to get it to work. But that's exactly what it says in the data sheet. But I can see that in my little example here that he's given me, that works. And you might go, oh, it doesn't work. I'll tell you what we'll do. I'm not going to load, I'm just going to show you this. Look, we're going to load some more data in here. I'm going to put 0x55 behind there. I do have to just increase that number there. So I'm going to load 2 bytes into the counter. I'm going to send 2 bytes. F5. So it's on build 20. Back into, see if I was quick enough. Build 20, which is what it's going to send. Stop. That's build 13, because 13 hexadecimal. Oh, I missed it. It's either not compiled, because I did something wrong. Compiled. Start. Let me just press the reset button. Does that reset it? Yep. I have another way of resetting the board. Blank check. There we go. Now, all that struggling was just to reset the chip, okay? But we can see that it's moved on to hexadecimal 14. I'll do that in decimal for you there. So we know we're on build 20. Good technique, eh? And here's my 55. And here's my end. My frequency is exactly 100 kilohertz. So I know I have a solution I can build upon. Thank you very much, the guy on the forum. Now, where am I with support? Support are just arguing with me. Not support, yeah, with Microchip support. They're saying no, the data sheet's correct. They're stuck on XC8. They don't know how to do PIC-AS. I will just keep hammering away at that, and it would take me many, many weeks to get them to understand the issue. It is a seriously long debate to try and get them to understand. But I'll create more and more videos, and they'll get it in the end. So my job now is to take this code here and convert that over into the library. And the library will, as I said, will have things like error checking, and so that we can actually detect when it didn't find the address. And what would didn't find the address be like? Well, if I come into my source code and I'll change the address at the top of the program. I'll change that to 76, compile it. I'm going into I'm trying to get there fast enough. Start. Hopefully I've captured it. Let me have a look. Found it. Yeah, I should have captured that. And if I now cursor along here, that's so 78 acknowledge, but that's on build 14 hexadecimal. So I'm looking for another build number, remember, because I've got that build number. And it says 76 NAC. 76 NAC. 76 NAC. I have no idea why that's sending out 76 three times. So my guess is that that's the 70. It's trying to send out the data three times based upon how many packets were in the buffer. So I need to abort that routine after the address NAC, but that's an implementation issue that I've got to work on. So what I've done there, I've proven that the whole setup is working. My job is now to turn that into a library that actually works. So it just says so we go back to the conventional commands of I2C start, send data, stop. Probably another day's work. Depressing. Back into PowerPoint. I'll get in there somehow. That's where we were. So, new chat, trying to get the basics working. Enjoy. I thought I'd share.